Hi. So today in this tutorial we will understand about the linear regression, but from the broader concept, from the mathematics involved in it, not directly from inbuilt scikit-learn algorithm. We'll try to understand the mathematics behind the linear regression. If we understand the basic concept, we can understand how we can minimize the error and how we can approach for the given algorithm. Okay, so go to straight directly into a Jupyter notebook, and first of all what we will do is to import the set of libraries, so NumPy, Matplotlib and pandas that we're going to use, and just import it. Now we are importing the same data, the data.csv. As you can see here, that the data we have CSV format like number of experience and the salaries of the employee. Okay, so import it, and if you can see that given data, that how many number of experience, accordingly salary will increase for the given employee, and the description is the total 30 number of data that we have, the mean and standard deviation, a minimum and maximum values given in the description. And let me plot the data how it generally looks using scatter plot. So in this way the data have been scattered around, the x-axis is experience and the y-axis is salary. So after that, this is that function. This is the cost function. So in the first, if you remember that you can just go directly into the first video that I have about the regression analysis and cost function. I have discussed about what is the cost function. So to just check that accuracy of a given model or algorithm, we just have to compare the cost. If the cost is very less, it means we are approaching to the accurate model or result. So in this we are passing input independent variable, that is x, and y is response output dependent variable, and the value of theta. Theta is the parameter, that is theta naught and theta 1. Theta generally we are passing here an array of 2 into 1. It means that it will have a 2 point, that is theta naught and theta 1. This is a very basic one. Okay, so we'll calculate the length of the data, that is m. So this notation that we follow here, prediction x dot theta. So if you remember that we have here that let's suppose I have hypothesis of x, hx, then I have theta naught plus theta into x. Now if I want to multiply it, how we can do that? We can simply just take a dot product between the input and output. Okay, but I can take the dot product only, it will multiply both, but first of all I have to append here 1. Okay, so after appending 1 here in the row 0, if we multiply both, so what will the result? For example, here is the house prices, so it will multiply with the given vector or given 2 into 1 dimensional array. So after multiply, the output will be 40 into 1 plus 0.25 multiplied by 2104 for the given example. So in this way we are multiplying it and we are finding prediction. This is the hypothesis. Now the hypothesis minus y, the actual value of y, and squaring it, that will give square error. We are saving square error, and finally we are computing the cost, 1 upon 2m multiplied by square error and overall the sum. So this compute cost will give us the cost function, and after the given cost function we will try to find out how much cost function will it give for the very basic uh, input input value. So first declare that function. After data, like let's suppose that we have a data in data frame, it will convert it back into the numpy array that we are using values, and after that we will calculate the number of length, how much rows that we have, and after we are appending it here numpy.1 number of rows and of 1. So this is the shape that is given here, and after that reshaping the data m comma 1, and both are appended to together with axis column wise, so it will store into y, and after same the data is of 1th column, and reshape it again and store into y. So we can, and after that theta have been initialized 0. So before that going into the detail, first of all we have to initialize the value of theta. So we can initialize at any value, but preferably we will initialize with the help of with 0 value. So initially we'll give it 0 value. So we are passing all these parameter into this function, and it will give us, return us some value, which is very because theta is considered as a 0, so that 0 will goes into, and prediction will be 0, and square error will be directly square of y of all the given column. What will be the output? So output will be something like that, okay, for the given data. Okay, so after that initialize xy. Okay, so you can just check the what will be a value of x. So if you check, so this was the previously we have input of x, we are just appending value of 1 here, and the y value will remain, will be this, will be remain same. Okay, we are just changing the shape. Previously it was it was the one dimensional, but now it's multi-dimensional just for computation it have been created it. Okay, so now the next part is gradient descent. So what gradient descent is, actually after computing the cost, we now have to minimize the error. We need to compute the value of theta in such a way that it will give us accurate value, and the cost function will be less. We will train that value. So that process is generally have a gradient descent. What we do here is create calculate a number of length, and will store the value of cost function. So j is refer here the cost function into this array. We are passing input, output, value of theta, and we are passing a one parameter also, that is called learning rate. Okay, so learning rate here is very important. Why learning rate is important? So whenever that algorithm learn, so cost function get decreases. So how much amount of cost function will get decreases, that depend upon the value of alpha. If alpha is large, the cost function will try to decrease at more number of steps, or higher number of steps. If alpha is very low, so the step will be very much low. So alpha, this something trade-off between the both of them. So generally alpha will take from not very greater, not very less, but approx 0.1 to 0 something 001. So it will just close to 1. And number of iteration we have to give, how much iteration that you have to give. We can increase it also until the cost function is decreased. Okay, So now we are provided iteration up to number of iteration that we passed here. First prediction x dot theta, that we need to multiply it, that is the hypothesis. That hypothesis will be passed to error value. So that error value you can understand from here. Okay, to minimize the cost function, we first differentiate it. To find the local minima, we differentiate it and we'll get this type of equation. Okay, so that 1 by 2 will come because this is constant, this come outside, and that 2 will come outside, that 2 and 2 will get cancel out, and then finally that differentiate with x will have finally this value. So what is that? X is multiplied with hypothesis minus y for all that training set and taking the sum of overall. So such thing is happening here. What we do is we are multiply taking a dot product of x transpose. This is the transpose value. We transpose it, and after that taking hypothesis minus y. Okay, so this is the error term. So that error will be multiplied with alpha multiplied by 1 by m, and that is subtracted with theta. Here what we do is, for the convergence, for getting the minimum value, we do theta j is equal to theta j minus j is that number of features. Okay, so we first have differentiated it, that is the error term. We have multiplied it with alpha, and we need to subtract it with the original value of theta. So by default we have taken original value of theta as 0. That will subtract it by the error term, and we get a fresh value of theta. That theta will be passed to compute function. Okay, so that will give you some value of cost function that will be appended or inserted into history of j, that we can visualize it, that with the given iteration, that whether the cost function is converging or decreasing or not. This process will continue until the number of iteration, and after getting the some value of theta, it will provide us that value of theta, and that gradient descent, that theta and j will be stored in with the help of this. So initialize give some value of alpha here. Okay, so we have provided 0.001. You can provide 0.01 also. So just check whether it is solving us problem or not. So 1500 is the number of iterations, and after that, that value of theta, which is a vector of two rows and one column. So I am taking 0, 0, which is the theta 0, and 1, 0, which is theta 1, and I want to print what is the theta 0 and theta 1 that I have finally calculated after 1500 number of iteration by reducing the error. Okay, so just execute it. It will give you theta naught is equal to 2665 and 12,829 as a theta 1. Okay, so that hypothesis is the final hypothesis that we got after 1500 iteration, that can be used to find any future outcome based upon the input. Now we show the optimized theta value rounded off to 2 decimal points. So here we have rounded off up to 2 decimal points. So to make that more complete, the visualization is that there's the small visualization. So I'm using mpl toolkit.mplot3d and import axis 3d. This is the library that you want to import for 3d uh, uh, visualization. And I am taking linspace. It means from the minimum of minus 50,000 to up to 5,000 is have been split into 100 parts against theta 1. So I will check from theta 0, I will check the value of theta 0 from minimum to maximum, and theta 1 from minimum to maximum, and we will check that what type of output that it will generally give. So our output is 2665. We will just check it up to 500 to 5000, and this is that 10,000 and up to 15,000, right? Okay, tick. Okay, so j value is numpy.0. Okay, so this is that we will first initialize that value of j, that is number of zeros. Okay, so that value will that is the simple initialization. We just swap the value of 0 to some other value by this nested loop. So initialize this with number of length of this and length of this, and that is a number of 0 of shape of length of this and length of this. So just initialize j value, and after that there is a nested loop of theta 0 value, and it will just traverse all the value from theta 0 to theta 1. Just visualize in your mind that there is a matrix made by theta 0 theta 1. So we go from 0 0 to up to theta 0 theta 1. Okay, so in each the case it will just take a array and put it into t, and that t will be a value of theta. So since we already know x and y, so that we put into compute cost, it will give some compute cost, it will store into j value, and after that it will plot that j value here. So just see, so it will take some time, and here we can see that this is the value. Here is a local minima finally we got here. So as you can see that theta naught is 2665. So somewhere around here you get the local minima, and that is theta 1 here is 12,829. okay, so somewhere around here 20,000 here you will get the local minima. Okay, so after that just plot the j history. So here you can get the clear picture of how our cost function get decreased. Okay, so gradient distance have been decreased like this way. So at this point or somewhere j theta that it got converges after 1500 iteration. We can also increase the iteration if you want to check the result, and so this total gradient descent implementation work is to reduce the cost. So what we do here, after getting the final result, we will plot the data and we check that it is a straight line passing all this given data point and satisfying all that given value. So what we do finally is, given hypothesis, we try to test some of the output. So if the person have 15 years of experience, what could be the average salary that will get? So he will get 19,000 1,95,104. okay, similarly you can also change here the value of alpha, so that you can just check how is that value is changing. Okay, let's suppose 0.01. So we'll change again, and we'll just find out. Okay, so this is the value. Okay, so come here and just replace the value with this, multiplied by 15, and just check. It will give 1,68,762, which is quite good. As you can see here, that the people who have 15 years of experience will have some salary of around this place. Okay, so accordingly, the hypothesis have been changed, so this value also gets changed somewhat. Okay, so you can just walk around and just check that how the value is changing here. So all these Jupyter notebooks I will just upload in my GitHub account, and just give you the link. You can go and just check how this thing is working, how you can just make from the scratch, and how to implement it in Python, and how to make that thing more accurate. Okay, so until then, just please share, and just give some recommendation how to improve that video, and please subscribe and share. Thank you so much. Stay tuned for the next video.